So far we've done the distributive rule. So that means you can, if you have an expression like this, A times, in brackets, B plus C, we go A times B plus A times C. Normally written as just AB plus AC. So that's the distributive rule. That's a D. Okay, it looked a bit of a funny D. So if you have an expression like this, A out of A plus 4, we can go A times A.
Can you hand it to Andrews? She's in Andrew's class. Would you be a moderator in that one?
We go A times 4. So A times A, we write that using power notation, A squared plus 4A. So let's apply it. What about this more complex one? These are called, each of these terms, that's a binomial term, or binomial factor. So we have a binomial factor multiplying a binomial factor. So to help you do this one, this is a little bit more complex. It basically involves distributive law. Let's go to this diagram. What I want to do here is I'll just add in, I'm going to help you visualize it. So if this is length A, and this is length A, what's the area of this squared? It'll be A times A, which is A squared. This length down here,
Yep, she's just made you a moderator now.
I'm going to say this is 2. So this whole expression here, that side length there is A plus 2. And along here, I'm going to say this one is 3. So that's the second binomial factor. So this total length here is effectively, you can write it algebraically as a sum, A plus 3. So let's keep going. You've got the number 2 here, so the area of this rectangle is 2 times A. Now the area of this triangle here is A times 3, and finally this little rectangle in the corner is 2 times 3. So finally, let's write it down. The expansion of A plus 2 times A plus 3, which is just the algebraic expression for the large rectangle, is just simply going to be these individual terms added together. A squared plus A squared plus A times 3 plus 2 times A and 2 times 3, which is 6. So let's write that down. So the final result is A squared plus 3A, let's simplify, plus 2 lots of A plus 6. A squared plus 5A plus 6. So what we want to do is we want to be able to come up with a general rule, a simple way of doing this. So what I'm going to do here, let me just draw a line over here. There's 2 ways you can do it. So this is the actual method without the diagram. How would we do it without the diagram? Can you see the pattern? So let's take the A plus 2 times A plus 3. Now I'm just going to get a different colour. Let's highlight some things. So these 2 terms, let's say that's A. I might use a different colour. Don't forget to include the plus 2 there because the sign is important, so I'll put that as plus 2. And then the last bit, we'll get a different colour again. What have I got? I've got black. Let's just treat this whole thing as one unit. So again, we're just going to apply the distributive rule. So that means we're going to take A is going to multiply this. So let's write that down.
Favoring away on your little magical box.
And then the next term we have the plus 2. So we want it to also multiply. Now I'll just highlight the parts here again in the colours we used. So that was the original single A. Then I had, what did I have? I think. Study this diagram carefully. That's the plus 2. Actually, I might just put it there. Just want to adjust my square there. Oops. And then finally, let's go back to black. You see the black part is all of this. It's just repeated. So what I've done there is applied the distributive rule. Let me just stop the video for a sec. Okay, now that we've done all that, hopefully you can see the parts, their relationship to the original. So now we use the distributive rule. We go A times A. We're back to the distributive rule up here, this rule. So you get A times A plus A times 3. So that was this term and those parts on our diagram. And then we've got plus 2, so we go 2 times A plus 2 times 3. And we end up with A squared plus 3A plus 2A plus 6. So there's the basic method. Okay, I'm going to give you one to try now. See if you can do what I've done on the left here, without a diagram.